Another day, another story. The brain's reward system is a complex network of structures and pathways that regulate feelings of pleasure and motivation. It plays a crucial role in reinforcing behaviors by making them feel enjoyable, thus encouraging repetition. Here are some key components of the brain's reward system. Welcome to Turbo Eminent Channel. Ventral tegmental area, VTA, located in the midbrain. The VTA is a group of neurons that release dopamine, a neurotransmitter associated with pleasure and reward. It is a primary driver of the reward circuit. Nucleus accumbens, NAC, often referred to as the brain's pleasure center. The NAC receives dopamine from the VTA and is critical for processing rewards and reinforcing behaviors. Prefrontal cortex, this area is involved in planning and decision-making. It helps regulate and control the impulses related to reward-seeking behaviors. Amygdala, involved in emotion processing, the amygdala contributes to how we perceive and react to rewards and potential threats. Hippocampus, this region is important for forming memories, including those related to rewarding experiences, which can influence future behavior. Dopamine pathways, the mesolimbic and mesocortical pathways are key dopamine pathways in the reward system. The mesolimbic pathway connects the VTA to the NAC, while the mesocortical pathway connects the VTA to the prefrontal cortex. When we engage in activities that are essential for survival, such as eating or social interaction, the brain's reward system is activated, releasing dopamine and creating a feeling of pleasure. This reinforcement mechanism encourages the repetition of these behaviors. However, this system can also be hijacked by addictive substances and behaviors, leading to excessive seeking of these rewards despite negative consequences. Understanding the brain's reward system has significant implications for treating addiction, managing mental health conditions, and improving overall well-being. The functioning of the brain's reward system. The brain's reward system is central to how we experience pleasure, make decisions, and form habits. It operates through a complex interplay of neurotransmitters, brain regions, and neural circuits. Key components and their roles. Ventral tegmental area, VTA. The VTA is a starting point for the reward circuit. It contains dopaminergic neurons that release dopamine when we experience something rewarding. The activation of the VTA can be triggered by primary rewards, like food and sex, and secondary rewards, like money and social approval. Nucleus accumbens, NAC. The NAC is a critical hub for reward processing. It integrates dopaminergic signals from the VTA and processes the rewarding stimulus. This region also interacts with the prefrontal cortex to influence decision-making and behavior. Prefrontal cortex. The prefrontal cortex is involved in planning, decision-making, and impulse control. It evaluates the long-term consequences of actions and helps regulate the pursuit of rewards. This area also plays a role in the experience of pleasure and reward anticipation. Amygdala. The amygdala is crucial for emotional processing. It helps encode the emotional value of rewards and is involved in fear and reward learning. The amygdala's interaction with the reward system can influence how strongly we seek out certain rewards, based on past emotional experiences. Dopamine's role. Dopamine is often referred to as the feel-good neurotransmitter, but its role is more nuanced. It is involved in motivation, learning, and the prediction of rewards. When dopamine is released, it signals that something important is happening, prompting us to pay attention and take action. This release can occur in response to natural rewards, like eating, as well as artificial ones, like drugs. Implications of the reward system. The reward system has profound implications for behavior, mental health, and addiction. Addiction. Addictive substances and behaviors hijack the reward system by causing excessive dopamine release. This can lead to a cycle of craving and seeking out the addictive stimulus, despite harmful consequences. Over time, the brain adapts to the high levels of dopamine, leading to tolerance and the need for more of the substance or behavior to achieve the same effect. Mental health. Dysregulation of the reward system is linked to various mental health conditions, including depression, anxiety, and schizophrenia. In depression, there is often a reduced response to rewards, leading to anhedonia, a lack of pleasure. Understanding the reward system's role in these conditions can help develop targeted treatments. Current research and advances. Researchers are continually uncovering new insights into the reward system. Some current areas of investigation include neuroplasticity, understanding how the reward system changes with experience and learning. This research can inform strategies for overcoming addiction and other maladaptive behaviors. Pharmacological interventions, developing drugs that can modulate the reward system to treat addiction, depression, and other disorders. A personal story, overcoming addiction. Consider the story of John, a man who struggled with opioid addiction. His addiction began after being prescribed painkillers for a back injury. The opioids provided intense pleasure and relief, flooding his brain with dopamine. Over time, John's brain adapted, and he needed higher doses to achieve the same effect. His life began to revolve around obtaining and using the drugs. John decided to seek help. He entered a rehabilitation program that combined medication-assisted treatment, MAT, with therapy. The MAT helped reduce his cravings and withdrawal symptoms by normalizing the dopamine levels in his brain. Concurrently, therapy helped him understand the emotional triggers that led to his drug use and develop healthier coping mechanisms. With time, John's brain began to heal. His reward system started to respond to natural rewards again, like spending time with his family and pursuing hobbies. John's story is a testament to the brain's remarkable ability to recover and the importance of comprehensive treatment approaches. The reward system and eating disorders. Case study: Sarah's struggle with binge eating disorder. Sarah had always had a complicated relationship with food. As a child, she found comfort in eating, especially sugary and fatty foods. This coping mechanism grew stronger during stressful periods in her life. By her early 20s, Sarah was diagnosed with binge eating disorder, BED. When Sarah ate, her brain's reward system would release large amounts of dopamine, providing a temporary sense of pleasure and relief from her emotional stress. However, this was followed by intense feelings of guilt and shame, creating a vicious cycle. Sarah sought help from a therapist specializing in eating disorders. Through cognitive behavioral therapy, CBT, she learned to identify the emotional triggers for her binge eating and developed healthier coping strategies. Her treatment also included nutritional counseling, which helped her establish a balanced and sustainable diet. Gradually, Sarah's brain began to respond more positively to healthy eating habits and other forms of self-care. The therapy helped her rewire her brain's reward system, making it more responsive to non-food related rewards such as exercise, hobbies, and social interactions. Sarah's journey highlights the significant impact of the reward system on eating behaviors and the potential for recovery through targeted therapy. Conclusion: the brain's reward system is a fascinating and intricate network that shapes much of our behavior. By understanding its mechanisms, we can better address issues like addiction and mental health disorders, ultimately leading to improved treatments and healthier lives. Thanks for watching. Request you to subscribe the channel.